So welcome to the part 3. I'm going to walk you through my code, and I go through my code as the game will progress through the code, and then I go over the parts that I probably skipped. So what happened when I start the game? This game just set the window. As you could see, the black window was a little bit bigger, and it goes and calls the start function. Start function is just down. Now a start function, it goes and creates the loaded login. So basically it creates all the logins for the players. So I go really fast to loaded logins and what the loaded logins have. So loaded logins, now we have the loaded logins. It's just a vector of logins, and all logins are inside of the vector. I use the vector because it has the low memory consumption, fast random access, and also the logins doesn't need to be in order. I could put them in order if I wanted, and maybe it would be faster search or split them into files, but that would take a little bit longer time to do. Now the functions are just add the new login, print, populate, check for duplicates because I didn't allow the duplicated login be there, that wouldn't make sense. Confirm login, search and confirm login, create metadata for saving, save all logins, load all logins. If I go to logins.cpp, now the populate function is just before I save it into file. I just populated it for testing purposes. I left it there in case I needed it later. Add new login, it's the function that will ask you to add new login. So it asks you enter the username, then check for duplicates. Username already exists, choose different one if it found one. If not, then the enter password and then login added. Please use it to login into game. Check for duplicates is a simple function. Also, I can say that this function has order n because it has to loop throughout all logins and check if there is any login that is the same. Another is the confirm login. If you want to log into game, it asks you enter username, enter password. Complexity is also order n because the function that searches and confirms has login order n because it loops and throughout all the logins and find the one to confirm it. Now the create metadata. What this function does for logins is it takes all the names and all the passwords and creates metadata for it and appends it at the beginning of the file, so I know every string has a certain size, and I will explain it a little bit later here in the code when I was loading it from the binary file and how I was saving it. So it will create the metadata for the file. Also I use this new function that is introduced in its for auto loop, so it automatically knows for each login in all of the logins I have, it goes through each login. I used it in more places than this one. Save all logins into file. I use the binary file, so file for save, write binary. Basically I created this file handle. I'll go through that later as well. File for save. It writes the integers first, all the metadata, all the integers, all the lengths of the strings that I used, writes that first, and then it writes all the strings in a binary format. And this is the load all logins from a file. Sorry, the comment is a bit wrong. So it does the same but in reverse order. So it reads binary. I have this loaded buffer. I show you again in my load functionality what it is. It's basically a memory array of bytes or characters, and it loads all file into that buffer, and then it processes the buffer and extracts the information I need. So so it get integers from a buffer or get string or whatever I need to get from there. So if I go back to the main app, so that was about the loaded logins when the game starts. So now it loads all the logins with the function I just showed you, and it goes and prints the menu. Now I go into the print main menu. There is the menu options in enum. You have the options to log in, create new login or quit. Now I go and get the input from a player. So if he if the user chose that he wants to log in into game, it creates the login info pointer to login player and it puts null pointer inside. Now I go and confirm the login with the function I showed you in the logins, and I pass the logged player inside of the confirm login. And what it does, if I go in, it takes the pointer to a reference, or a reference to a pointer. So instead of me have to pass a pointer, then return pointer, then check if it's okay, I just pass one reference to a pointer. That saves me time because I can pass boolean if it was successful, and if it was, already I have the pointer I need to the logged player that was extracted from the vector of the possible logins. So if I put the username and password was correct, so if the boolean was true, I have this logged player that is already inside of this pointer, and I can pass this logged player into my next function, which is print load menu. Also, I have this create new login if I need. I showed you when I was going through the game, or quit. Now if I go to print load menu, so that has the start new game, load game, or quit. Now I want to get input from user again. I want to load the game, so I have to check if the logged player that I just got the pointer to the logged player has the save. If he has the save, of course I can start the new game from a save, because I know he has a save and I can go and load everything I need from the file. If he doesn't, I start the new game. So I start the new game first. I show you how this looks. So I pass this logged player into the new game. Now I print the intro to the game that is just down here. Welcome to the adventure game, blah blah blah. That's the intro. Now I go, I create a player. I just put some no name for him, whatever default stats. I can get random coordinates here, what I was saying earlier, that it doesn't need to be 0 0, but for me it was easier. And now I can go and customize player, as you can see the comment here, and I go player.set name, set his name first, and then I go and customize character. So I go into this customize character. What this function does is takes the player and customizes him, so it adds strength, or it adds agility, or adds health with whatever user type in. If I go back, I go and create the loaded buildings. Now loaded buildings is another class which holds all the buildings for my game. So I go and show you the loaded buildings class now, and as you can see, this keep tracks of all buildings. I use the gain vector of a buildings for loaded buildings. It's low memory consumption, fast random access. I thought it was the best option here. And the buildings doesn't need to be in order, because when I'm putting pointer into map, as I show you later, I will be just randomly accessing the vector anyway. So I have a constructor, getters and setters. If I go back, I have load all buildings from a file. So what it does the same thing. Goes read binary from the buffer character, and then manipulates the buffer full of characters, and load all buildings from it. Show you that later. Now I have loaded objects. I can go to the loaded objects. It's the same as loaded building. Instead of buildings, the objects are here. Loaded enemies, same as loaded buildings. Enemies are there. Then I go and create a map for my game. So what is map? I walked you through my plan. I walked you through my plan. So the map is just a vector of map fields, and then it has x and y coordinates. I have here a default x and default y length is 5, so I can change it here. My map will grow or shrink. accordingly. There is not much functionality in this map. What does the map populate do? It just puts the map fields into a map, and I reserve the size of the vector that I don't need to resize it, so it speeds up the process a little bit. And I go for each X position, I go and create all Y positions I need. If I would switch these X and Y, so for each Y I would create X, then I would have to little bit adjust my algorithm for inserting the buildings pointers into map. Now I have this pushback. I use this standard move map field, so it's move enable again. I use all my constructors to be move enabled. Instead of copy the map fields, I just move them, so that should speed up the process a little bit as well. And I show you example of how does it work at the end of my code walkthrough. So that would be about the map. Also, this has the complexity of order n squared. I don't really think that you could populate it faster, because you have to create each field, and for each map, if it's 5 by 5 is 25, so it grows exponentially. Now these ones are the functions I was talking about. So all buildings that I created, and I put all buildings pointers into map. So into each map field which has building pointers, I'm going to put into different map fields different building pointers that I can manipulate. It's really easy for manipulation. Also, if I needed to change something, code looks better. So I go here, and this is order n. This function just loops through all the buildings, loaded buildings, and put the pointers into a map. And that is the offsetting vector, what I was showing you in my plan, how I was calculating the offsetting vector. So I use this auto loop again. So for every building, as you can see, it's really easy to read as well. For every building in all of my buildings, I go create the offset for that building. So I get the building's X position, multiply it by length of the map, get the building Y position, add it. Sorry. Now, and I go to my map, get the field reference for that field, which is offsetting vector, and I add building pointer of the building to that map field. So I just populate the whole map. I do the same for the all object pointers, and I do the same for enemy pointers. For object pointers it's a little bit more complicated, because I have the items when I'm loading from a save that can be already equipped. I use this is equipped, but it's basically an integer -1, because I know that in map I don't have any minus positions, so I just get object X position, and if I know that it's -1, I put is equipped, and as you can see equals -1 there. I know that the player has this object, so I pick up that object. If the object is key, I know that is key because it's a -2 in X position. That means that the key is the object, and as you can see I populated, but it's all loaded from a file, but I was for testing purposes I was populating it in here, and as you can see the keys have -2 in positions. And then if the object is used key, or any used object which I use for the cape of the king, that king picked up the cake, because a king as enemy was also a player which can pick up the items. I can decide to redo something after a certain amount of time. I can put the keys back into the buildings and let the player build more buildings or castles. Now if everything is okay, and if the if the object supposed to be in a map field, I go and I put it in. Next is the player set position pointer from a map. So I suppose I show you my player class, that you can see how it looks. So my player class, this will be a little bit longer talk, has everything derived from a person. So in a sense, I just have to show you a person, and I show you the person.h. Now, person has the name, strength, agility, as I was showing you in my plan, so everything is as it should be. Map field and inventory. This one I'm using a lot because it's the position pointer to a map field. So it's a pointer of a map field that the player has with him. So player knows on which map field he is, and he can adjust all the pointers of the map field. So it's really easy for player to pick up the objects, drop the objects, change everything he needs. Now, why I have these private functions and they're all virtual functions? It's because when I want to do something to a person and I want to do some part before I do some part with the enemy or player. So I go, for example, into my which one? It has a print. It will be really easy to explain. I go to my print function. As you can see, the print is normal function. It's not virtual. I go into my print, and what print does, you can call print, and I don't need to override print in any of the player or enemy classes. So I call a print, for example, on enemy. Okay, it prints the name, level, every stats that are same from a player's class. Then it goes and do a print. Yeah, so it goes to my person, and person has a do print. Sorry. And person has this do print that the function will call. Okay, but I'm calling this from a enemy, for example. And because this is virtual void do print, enemy goes and overrides that virtual void. And as you can see, it's a virtual void do print constant final override. Also, it's private, so nobody can call it from outside of the class. And it's called only from a player's class when somebody calls a print. It goes here, goes to do print, and just prints out additional experience add for the enemy. So it's very, in sense, it's really easy that you can print something before the enemy, and then you can just override the do print for the enemy and add whatever you need to the print. Also, it's constant final override. What does this means is, constant means that it doesn't change enemy class. Final means that nothing else after this will override the do print. So if anybody takes enemy as its derived class, he cannot override the do print because it's the final override. Also, it speeds up the process for the compiler. If he sees that it's a final and override is the possible improvement in the speed. Now, if I go back to my person class, so I showed you the do print. There is the added functions, and as you can see, you can go north, south, east, west, and as I will go through the game, I explain most of it anyway. So I go back to my game. Probably will be easier if I just go here. So I go and set this position pointer from a map. What it does is just basically person has this pointer to the map field, and it goes and gets the field reference. So it gets me the field reference I need for the position pointer in my person. Then I just print the player that I see what are his stats and where he's standing, and then print map field you stand on is basically print all the buildings and enemies and everything. Now I go into the loop. So I have this sentence that was from my previous CA. So I split the sentence into words that I can parse all the words. Now I create a timer that I can time how long it takes for one parse function call, and then I just print out the parse function took that many milliseconds. So I go into the parse function, go into my parser CCP, and as you can see, it's a lot more condensed than my previous parser, and I made it a lot more clearer to the user if he is going through the code. Also, the complexity, worst complexity inside of the parser is order n to the power of 2, because it has to, for example, when I'm searching in my inventory that I want to drop something, I have to search first from all the possible items I can drop, and I have to match the name, and I also have to go through all the words that I wrote into a sentence, because that's how my parser works, that he can write whatever he wants. I want to drop this item. If I would change my parser, I possibly could go from order n to the power of 2 to order n, but it is usually just a matter of few milliseconds, because the players don't really write more than like 5 words in a sentence. So I don't think so you will have a massive savings in time wise. If it would become a problem, I could change that. Now I go what this function found in sentence does. It's also from my previous code. It just goes and checks if in the sentence. I improved all of the code. As you can see, it's the auto loop, and it's a lot shorter and clearer, that for every word in a sentence, if the word equals to the word that I'm searching, I return true. If it doesn't, I return false. So it's really clear if you read this code. So if I found go, I can go check for the direction that he wants to go. I made the shortcuts that I just go n is go north, SEV it's south, east, west. What this does is checks the direction. Okay, the go was there, I'm going there. Where do I want to go? I want to go north. Okay, I pass down the player and a map, and I go player go north in my map. If that equals true, so I go now and I show you all of the functions look the same. Player or person go north, because that's the overridden function. Order complexity is order n, because I have to go and check for loop for all the map fields which one will be the one that I want to go on. Now I go I want to move, so I go +1, because that's for the north in a y position. I'm gonna for auto in map fields. For each map field in my map get field references, so I get all of the field references in my map, and I check every map field. If map field that gets coordinates equals m position get x coordinates, a map field get y coordinate equals the move position. So if I found a field that I wanted to move on, because I moved +1 in a y, and if the y equals to the one that I moved in, I set this position pointer in my player or person, and I return true. Okay, I moved there, because the position is already set here. If not, I check if we reach the boundary, and if I reach the boundary, I tell him you are at the map boundary, you cannot go more north or south or whatever. As you can see, there is the south is exactly the same, east is exactly the same, and same is the west. And there is all the functions, that is the south, east, west, or you cannot go there if you entered something wrong. That was for the go for fight. Now I show you the fight, what it does. Fight is if I fight if exist something in my map field. So I go here, fight is if exist in a player. That's another function of player. Now I go and get one pointer of the enemy I want to fight. So I go position pointer, that's my map field. I get the enemy I want to fight. I go here, get enemy I want to fight. Okay, I return some enemy. Okay, if the enemy, there is nothing, there is nobody to fight. If the map field is empty, there is no enemy. If there is some enemy, I just start the fight with the last enemy in my vector, because it was easiest for me, and I just pop it back. So it's really fast. So if there is somebody, I fight. If nothing, return false. Then I go to fight simulation down here. Just give me a second, drink some water. So I go to fight simulation down there, and what this does, it's while true, it's so I'm looping while this is true, so it will be true until one of the enemy or a player dies. And if I have this swing enemy or get hit by enemy, and these two functions are here, so I go through them first. So swing enemy, I can get a bonus strength on bonus agility and a random number that just makes it a little bit random. Add bonus strength plus that random number, or add bonus agility. These numbers are on top. Bonus agility is 30, bonus strength is 10. And then I just calculate how much damage I dealt to the enemy. Get hit by enemy, it's exactly the same. How much damage I take, and critical strike. I used calculation for critical strike that I get agility, and if the agility is for example 50, that's 50% chance to get critical strike. So the higher agility, the higher chance to get critical strike. Now if I killed somebody, I get the experience of that enemy. I don't think I need to show you the function, it says what it does. And then if the enemy has an object in inventory, if it's not empty inventory in enemy, for example the king, I could do it for any number of enemies if I wanted, but I just didn't really bother to give every enemy something into inventory. I just showed that I can do it with one enemy. So if there is something in enemy's inventory, I get that object pointer and remove it, and I drop it onto the field, so it says that enemy dropped object, and then I break. Also, if I get hit by enemy and I die, so this says not, so I cannot get any more hits because I'm dead, or I cannot get any more swings on enemy because the enemy is dead. It just prints out these things. You are dead, responding in random position, as you could see that print out. Get out of my inventory one item, set the experience to minus half, set position pointer to be the random pointer, and then add wounded enemy, so add the enemy I was fighting for back into the map where I was fighting with that enemy, and I heal myself totally because I respawned, so I have full health. And then fight simulation ended. That was for fight. Now for use. If I want to use some items, so for example all of the keys. So there is the player use all keys, and I go and go into my inventory and I use all keys in inventories function. Use all keys. So what this does is I go and I loop through my inventory, as you can see again, constant auto object in object pointers. If I found the 3 keys in inventory, I use them, and I delete delete them, pop back. So I swap for fast remove from my inventory, and pop it back, so there is no more keys. Also I set the positions to be the used keys, so when I'm loading it from save, that there is not the keys in my inventory. Then I can rest. Oh, I didn't show you the function rest. It's just basically heal player totally, that's all. Equip if exist. I pass the sentence, go down, I go into my inventory, set to equipped, go here. If the number of equipped objects is full, you cannot equip items. I go again loop, so for constant auto for every object in all of my object, if the world equals the object that I want to equip, and the object is equipped, the object is equipped. If not, I equipped the object. Complexity is not the best, but as I said, the player doesn't type that many words into the sentence. Unequip, similar to equip. Visit, what it does, visit building just takes the key from a building. So if the position pointer has enemies, I have to defeat them. If the position pointer has a building, I go and get a key from a building, if that building has a key. So get key from a building, and I check here if the building get key. So if the get key pointer equals no pointer, there is no key in the building. If it's not no pointer, I return the pointer to the key. And also I did this with reference to the pointer because it was easier. I could have used boolean return, plus I already got the key what I needed as a pointer. So that would be the get key from a building when I type visit. When I type pick, I just made a function in the player pickup if exists, and I passed the vector of the string sentence. Also, the complexity is not the best, but as I said before, the player doesn't type that much. If he can something pick up, he adds it into inventory. So add inventory pointer object. This is just to check if it's equipped. If there is some problem with the code, for example, like there is some item on the floor that it's equipped, like it has the -1 on it already, but it's not really possible because there is no minus fields. But if I would change my map or something, then I would just tell that I'm going over the limit of equipped items. If not, I'm going to equip the item. Sorry, pick up the item. Add the pointer into inventory. If I want to drop, it's opposite. I add the pointer into the map. Show is just a print inventory. Look, I just print map field. Look around, basically print map field. Now for exit, that's the and a save there. Basically the both are same almost. What it does is I set the X and Y position, that's where I use it, because I want to save the player and I need to know his X and Y position when I'm going to load him where he was. So I set the X and Y position in a player MX and Y position pointer and get X, get Y, and I put them there. Now I go set to file. So now I think is the good time to show you, because there is only a help command left and no keywords entered if you don't enter anything. So I think so now it's the good time to show you what it does. So I created this file handle class that helps me with handling my file. So I go and I show you my file handle. What it is, it's just a class that takes the resources of a file. So it's just a file pointer. But it has constructor and destructor, which basically closes the file. So I don't need to type f close, but when I'm not using the file, it automatically closes. I know it's not the best because the constructor shouldn't have the errors in constructor, but because I wasn't using the functions from a library that were already constructed, I had to make my life a little bit easier, and this what was recommended by the person who wrote the C++ when I was watching on the internet, and I think that's the link here. So I created this file handle, and I have in it the write characters, write character buffer, write integer, write integers, all the functions I needed to get the information. But what the functions does is basically write character buffer. So that's, I called it write string or write character buffer. I pass a string in and I use the fwrite function of the file, and I write the string as array, so C string, then the size of the character, and then how long was the string into the file. Same for integer. I write integer as size of integer 1 because I want to write one integer into the file. Write integer is the same, just more integers. I didn't use these functions, but I had them in if I wanted to use them. So read in integer from file at pointer if I was. Actually I might use them somewhere, but I'm not sure. Read string from file at pointer as well. So I just passed the pointer and how the pointer was there already when I was reading the file, but how many of characters I want to read from the string. But which one I used was the read whole file into my buffer. So this one I can explain you. What it does, I go and seek how long is my file. Then I create the buffer size, and I go and rewind the pointer that it starts again. Now I create the unique pointer, so I don't need to be afraid of a new and delete and memory leaks. And I call it my unique buffer, and I make unique character array, and then the buffer size. Now I go the how many I read, that's just for check, and I go fread my unique buffer.gets, this gets me a pointer, size of the buffer, size of the one character, buffer size, and mfile. So this one is the save fread underscore s, and then I return the my unique buffer. So what it is return type is unique pointer char array, and then I can manipulate this buffer of characters. So I have a whole file which is just the stream of the characters loaded in a buffer. And what I do, I use this buffer manipulation to get all the informations I want. So get string from a buffer. I start from the top. Complexity for all of them is constant order, so it's really good. And what it is, I have this buffer pointer that I pass into the function, so that's my unique pointer, and this is the offset I want to get some informations from that buffer. So I go and I want to get integer, so I go integer that I'm going to return, and I go mem copy, so I just copy the memory from the location, because everything is the bytes. So bits, sorry, it's a bit. So I go add readed integer, so I just put the memory copy there, size of the integer, then the buffer pointer plus the offset, so I know where I start and how long it is, the size of integer. And if that equals 0, that's okay because it's copied. Also the memcopy underscore s is the save memcopy. If not, error occurred. Now I go and change the offset because I'm passing the offset as a reference, and I change the offset and I return the integer I just read from my buffer. Get character from a buffer is if I need one character. Same with the integer, is a memcopy. Now if I want more integers, I do the same. I just call this get integer more times for how many I want, and the offset automatically changes. Get string. So for the length of the string, I go and push back that many characters, how long is the string, and I return the string of the characters. So this would be my buffer manipulation functions. Also I created them because I was working just with a file, but there is already created functions with a binary files in fstream. You just add the binary to it. Now if I go back, so that would be my exit and save. So I show you, I suppose, the save all buildings into file. So what it does, that's the file handle I was just talking about. Creates me a file that will write the binary into the file, and I'm going to write integers because I just created the metadata. So all the lengths of the strings I have there, I just save it first, and after I saved all the strings, I saved all the integers, and every building knows how to save itself into the binary. So I go for auto again. In each building of all of the buildings, I save one building, and I go and write, because the name is first, I write the character buffer, description is the second, I write the character buffer, integer position, so write integer and write integer again. When I'm loading it, I go and get a string from the buffer, and as you can see there is the offset. I pass the offset, and offset changes automatically. So offset, after I read the string, offset changes, I read another string, offset changes, then I read integer, and then I read integer, and offset changes automatically. Um, so that would be save, help, and then no keywords entered. Now I wanted to show you the about the timer. So I did this why I chose vector, and I'm going to show you the difference in speed of the vector and the list. So I just created this vector, I put there 1,000 elements, and I'm going to populate it, and I'm going to pop back with a swap. And how long does it take, and how long does the pop front, for example, does take for the list. So if I have this, I run this, as you can see the vector is first. And this took for a vector 90 milliseconds to populate and 837 milliseconds to delete for list 707 and 608. But what happened if I change this? List 120, 80, 40, vector 175, 740. So it depends as well a little bit on which one function is called first. But if I just would call one at a time, and as you can see the time is almost the same. So vector with the swap, the deletion is same as in a list, but I'm saving the memory, so I chose this data structure. Also I can show you this. I can use swap and swap the locations and then the pop back, or what I can do is use this new move semantic. So I move the last one, but I have to move the data. If I don't move the data here, what happens? I have this with a vector, okay. As you can see, it takes 1.6 seconds. Now, if I move the data back in, so I get the data, and what it does is the move, it just takes it, moves it into the position, and I don't care about swapping last, because of course I know I'm going to pop the last back, so it doesn't matter what is really in the last one. So if I do it with the data, it took again the same time as if the swap would do. You can choose whichever is more preferable for yours. I choose swap because I think it's clearer in the code. So that would be for demonstration why I chose the data structures. If I go really fast, I showed you the buffer manipulation, showed you the parser, print utility. Really, that's from my previous project. Don't need to really show you string utility in my previous project as well. User input utility, very easy from my previous project as well. Now building.h explained in my the plan. Also, these constants I used for all the default building name, description, and so on. You cannot use strings, you have to use the char array if you want to use it as a static constant. Have enemy, talk about that file handle, I talk about inventory as well, loaded buildings, I talk about all of the loaded objects, login info, I talked, map, I talked, map field, I talked about also in my plan. Object, talked about person, I talked about player, I talked about timer. Timer is from the code that we had from college. In my person, I talked about all of the do, print, do, save, and I just check really fast the added functionality if there is something. This is just getter setters. Yeah. And there is my enums that I used, so health, bonus per level, the experience boundaries and the map boundaries if I wanted for random coordinates. This I showed you the start from save, start new game, and Also, I could tell you about start from save. As you can see here is the, it's in my startup. I have these constant characters, and I have this file name, building, and enemies and objects and players. And these file names, because for each player has a different login name, I just use that and I concatenate. So I put a folder for save. I made like a folder where all the saves go, and I get the name of the player because I know that every name is different, and then I just added the file name for it to be saved in. So that's what I used for saving. And